Okay, so we've got this unemployment file to download. Today we're working on loops. So all of today is looking on loops. There's three fundamentally different kinds of loops. There's some other loops also that are kind of around for historic reasons, but they're like not really current. They don't give us anything different from the three main loops. So we'll just focus on those. So we're going to go ahead and download that workbook and open it up. So here we have, what is this? Oh, so this is just like every county in the United States. And then the FIPS code. I forget what the FIPS stands for, but it's like this is like the number that the federal government uses to identify a particular county. So Baldwin County is 1003 and so forth. All right, if we look at the code there's already some code in this workbook. There's a module called mod web query. And what I did after the regular web query wizard, the old legacy web query wizard went away, I said, you know what, I'm just going to write some sub-procedures that allow us to just generate that same kind of legacy web query from code without having to record it. And so these are here kind of for your use, some comment about what it does, but you essentially tell it where to go, give it a URL and some other optional things, and it just goes, it automatically generates the web query, it fetches the data, puts it back where you told it to put it, and then deletes the web query. So you can use it over and over again without building up a year supply of web query objects in your workbook. So module 1 has a couple of things going here as well. So here is something called import county data. So you pass it a FIPS code that we have on that list, and this will, what does it do here? It is, so this workbook worksheets add. So it's calling the add method of the worksheets collection of the workbook, and it's passing a parameter telling it to add it after the very last worksheet. This is actually kind of a long statement, but we know enough to deal with this now. So we're saying after, and then we're actually giving it a worksheet to put after. Even if we didn't tell it after, we'd put it somewhere, but I'm putting it at the very end. So this says, okay, look at this object, this workbook. There's an object in that object called worksheets. It's a collection of all the worksheets. And so we played with that last time we were together. So what do I want to put as an argument here for the worksheets collection to identify a particular worksheet? Yeah, just put a number, the ordinal number. And I am asking, and what am I putting here? I'm putting the count of the worksheets class. So if there's 7 worksheets, I'm going to put a 7 here. So I'm telling it to go after the 7th worksheet. It's going to go at the very end of the worksheet list. So every worksheet I have there, the new one's going to fall in right here at the very end. Then I'm calling create web query, which is over here in mod web query, in this module called web query. I'm giving it a range on where to go. So we've created a new worksheet. We've called it S. We've bound a variable onto it, S variable. So now this refers to the newly created worksheet, and range A1, that's the first argument. It has to have a range to put the results. And then here's the URL that has built into it. Oh, here's something we haven't seen yet so far. So I think a couple of days ago, or a couple of meetings ago, when we saw we're making sub-procedures, I told you these parentheses always go there at the end. They go in automatically. But this is what they're for. This is actually a thing called a parameter. The only thing I can do inside these parentheses, I can declare a variable, which is what I've done here. But it's a special kind of variable called a parameter. It receives its value. It gets assigned a value. It takes on a value when you call this sub-procedure. So here's the name of the sub-procedure, import county data. Here in this sub-procedure called get data, I'm calling import county data, and I'm saying, hey, you're expecting a value. I'm giving you a value here. So this value, 20,063, gets assigned into this variable FIPS. If I was to print out FIPS when I run this procedure, it would call this one, and it would put this value into this variable. If I say print FIPS, it'll print 20,063. So it's actually then, I've got a string literal here that ends there. I concatenate in the FIPS variable, whatever value was passed in, and so it's putting that number into the URL that we're going to use to create the web query. So I'm going to go ahead and just run this, and take a little minute because the website that we're working with here at the Bureau of Labor Statistics or wherever it is, yeah, BLS, is not the fastest of websites, but it has now brought back a new sheet, just whatever the default name is. and it's brought back labor statistics for that particular county. What's the name of that county? It's Gove County. It's the county I'm named after. Wouldn't you all like to be named after a county? It's me. Gove County, Kansas. It's actually pretty small. Labor force. Look, the county's labor force in 2008 was only 1,047 in the whole county. It's a pretty small place. And see, we get pretty recent data. So it looks like we've got data for July of 2019, but that's projected. We've got real numbers for June of 2019. So it's, this stays up, pretty good. Oh, wow. It's kind of the same number of people. 1432, and what did we have? 1470. They've got less people now in the workforce than they did in 2008. Okay. So this is just to get us a couple of things. One, to kind of get you a little more exposure to some of the great things we do with VBA. We could create a sub-procedure that does something great and then just call it with some values. And, you want to get, for Utah County, go find the number, just call it with that, and it would bring back a sheet with Utah County's numbers. But this will also now give us some data to work with as we're dealing with loops. So shall we dive in? Let's go ahead and do that. Okay, so I'm just going to work above these procedures that we have here so far. And so what I would like to do, in fact, maybe what I'll do is I will just, let me kind of work right inside this get data sub-procedure. Now, as you might guess, what I really want to do here is I want to get this unemployment data for every county. There's like 3,000 of them. I don't want to do it by hand. Fortunately, I've got a web query kind of set up here to pull that data in. So, but I don't even want to have to write this 3,000 times. So that's what the loop's going to be really good for. So let's go ahead and just do a little more specifics with the do loop. So we've seen the do loop, but let's go ahead and get it set up. Do and loop. So this would get the data for Gove County over and over again because this part's hard-coded. What we want to do is have some expression that will, the first time through it will get one value, the second time through it will get a different value, and so forth. So I'm going to go ahead and just disable the part that actually imports the data for now. Because I don't want to, for two reasons. One, it would be rude to keep asking for that data when it's not really part of what I'm working on right now. Right? The Bureau of Labor Statistics maintains this server. What do they charge us to get the data off this server? They don't charge us anything. Well, in one sense, it's a government agency, so they're charging us through taxes at some level. But especially if this was like some commercial website, I'd want to be very careful about that because someone's paying for it. Is it free to send that data to me? It's almost free, but it's not free. And so we just want to be sensitive and not be abusive to resources out there that we're consuming without paying for them. Okay, so let's just get this. Let's start off. So I want to run this line, once with 20,063, once with 20,064, with every single one of those. So I'm going to start off just by getting my code to print off the series of numbers that I want to use with the import here. So let's do this. Let's declare R as an integer. No, let's do it as a long integer. What's the difference between integer and long? Yeah, integer is plus or minus 32,000. Long is plus or minus 2 billion. So 32,000, truth is, would be enough for this example. But anytime I'm using something that's going to refer to a row, which is what this variable is going to do, I prefer to use long, even though it takes an extra byte, just because sometimes I do things on rows that go past 32,000. And if I've got integer there, it's going to try to go to those higher rows and it'll fail because there's not enough room to store it. So I just like to use long every time I'm referring to a row. Oh, there's something else here that's new. So here's sheet 1. So here in my Project Explorer, it says here's sheet 1. By the way, in case you missed it, it's sheet 1. I mean, it has the name twice here in parentheses. These are actually two different names. This name inside parentheses is what shows on the tab. This name, technically, it's the code name. It's like it's a secret agent. It's got a code name or something. But it means it's the name you refer to the workbook through code in. So I can refer directly to this sheet by just calling it sheet 1, or this one just by calling it county, even though the label says counties. And by the way you set that, if you wanted to set that code name on a sheet, you just select the sheet up here, and then you just type the name in here, and that will set the code name, which can be a little bit, can be handy. Okay, let's zoom back out. So what I would like to do is I would like to do a debug.print of my worksheet name, which is county. That's the object name. This name actually, this object has a name. County dot, now cells. This will let me refer to any cell on the whole worksheet by giving it 2 indices, a row and a column. And by the way, anytime you have an ordered pair in VBA to refer to a cell, it is always row first and then column, row then column, always. So the row that I'm interested in is going to be R, and the column, I'm just trying to get to these FIPS codes, and those FIP codes are in column A. So I'll just put a 1, column 1. So let's actually give this a value. So let's start R equals 2. Because I think that's where my first FIPS code is. And that's actually for the whole county of Alabama. So all of, when the Bureau of Labor Statistics is reporting this information, they'll aggregate everything up to Alabama, all the counties, and they'll give me actually numbers for Alabama. So I'll just go ahead and use those as well. So this should, so if I've done this right, this should print out what Alabama is, 1,000. So I'm going to use F8 to run this one line at a time. Hey, by the way, why does it skip over the dim statement? Do you notice that? F8, it skips right over the dim statement. That seems weird. Why did it skip it? I'll tell you why. So it turns out that when you go to run this subprocedure, the interpreter says, all right, before I can even think about running this, I got to make sure I have enough memory for all the variables that are declared here. And so before it starts to run, I mean, as soon as you say I'm running this subprocedure, before it does any line of executable code, it looks through the whole subprocedure, finds all the dim statements, and it allocates all the memory up front. So the memory gets allocated before you start running. So that's why it doesn't step through it, is because you can't, it's already happened. By the time you get there, that's done. That's already been processed. It's a little bit weird. It doesn't happen in order, but everything else goes in order. Okay, so now I'm setting R equal to 2. And hopefully, oh, I really want to print the value. I didn't put value on here to be okay, but value is the property that I'm after. I'll press F8 again, and sure enough, it's printed me off that FIPS code. That's pretty good. Now, I'll hit F8 again, and now it's going to print. See which one comes after Alabama. It's anyone from Alabama? Autauga. Autauga County. I'm sure I'm not pronouncing that correctly. So what do I expect it to print when it gets right here? What number? Yes, okay, good. Yeah, so the comment was going to print the same one, because I haven't ever done anything to change R. Now my intent here is to say I want R to increment by 1 each time we go through this. Good, so maybe what I'll do here is at the bottom of the loop, I will come in here and say R equals R plus 1. Now R is still 2, so when I step through this again with F8, it'll print 2, or actually it will print that number up there, 1,000. And then hopefully it'll now do the next one as I step through it. And now it's picking up, how come there's no county 1002? It was Gomorrah County, and it got wiped off the map. I don't know. Oh, 135. Looks like they figure all these counties in Alabama, they're all odd counties. And so let's just give them odd numbers. I don't know. But actually, I think you're right. I think they are all odd. Oh, no. Yeah, Arizona's got some even counties. So Alabama. Yeah. The whole state is odd. Yeah. Okay. So that's pretty good. So here's the do loop. But what's the problem with this do loop? Yeah, I don't have a way out. And then we talked about this. We can put the exit clause either at the top or the bottom, but there's actually two words that we can use. So let's take a look at those now. I'll put this up at the top. My preferred place to put the exit clause is at the top of the loop, unless there's a compelling reason to put it somewhere else. So here I'm going to say do until is empty. So is empty is another way for us to tell if a cell is empty. It's actually a function. I pass a cell to it or any other expression, and it will tell me if it's empty. So I just want to pass not the value of the cell, but I want to pass the cell itself. So looking at whatever row we're looking at, column 1, I just want to know if that is empty. So we'll come along, we'll print that one. It's not empty. And let me go ahead and on my print, I'm going to print R as well, just so I can kind of see that. Now, one more thing, we've talked about this already, is do events. I'm going to put that in. Anytime I'm making a do loop, I'm going to put do events in here. The other two loops we'll talk about today, they kind of have a natural way to end. Like if you have to work pretty hard to put the other kinds of loops into an endless loop. Do loop, you can put a do loop into endless loop pretty easily. So I like to put do events in there. What does do events do again? It just tells the interpreter to pause for just a moment and see if you're trying to get its attention so that you can interrupt the code. And from here, I'm going to go ahead and just run it, and it should run the rest of those off. It'll take a minute, well, not maybe half a minute to get there. There are 3,000 some odd counties, but it's running through and printing those off. The vast majority of the time that this loop takes to do is actually the printing. It's because we're printing this off that it's taking so long to do this. 3,274 or 73 apparently. Okay, so far so good? Yes. How did I get the count in there? I said debug.print R, comma, and so it's just printing the row that we're actually looking at that point. Yeah, I snuck that in pretty quick. It was only 2 characters, R, comma, space 3. Question here? So debug is an object. It has methods. It has 2 methods, actually. It's kind of it's a wimpy object. So debug is an object. It has a print method, and what it does is when you call the print method of the debug object, it just prints whatever you give it to it into the immediate window. There's the other method is called assert, debug.assert. I have no idea what it does. I should probably read it sometime because I really know the debug object. There's only 2 methods, but I've never had the urge to use it. Just debug.print. Other questions? Okay. So we can do until something is true, or we can do while something is true. So I can put the keyword while in here. And so maybe instead of is empty, I'll say do while the value is greater than a 0-length string. It turns out the very smallest value you can have in a string is a 0-length string. A string with any character in it evaluates to be larger than a 0-length string. And the truth is, strings are, it might seem strange to you, but strings are either bigger or smaller than each other. Which one do you think is bigger? Period or exclamation point? For characters in a string, what do you think? I don't know. Question mark, period, is greater than exclamation point. It's either true or false. It's true. Period is bigger than exclamation point. How does it know? Say it louder. I heard it. ASCII, yeah. Remember, every character gets a code. It's mapped to a number that it gets stored in memory. So we could actually ask what the ASCII value of the period is, 46, and the ASCII value of the exclamation point, is it going to be bigger or smaller? It's going to be smaller. It's 33. So they just said, listen, we got to have a code for each one of these characters. Exclamation point, 33. Somebody decided, I don't know who decided, somebody decided that. Period, 46. And so when you're doing comparison on strings, it's actually comparing based on the underlying numeric representation of the letter. Question? Is it better to do the is empty method or the do while method? So the question is it better to do the is empty, or is it better to do a comparison like this, to where I'm comparing it to a zero-length string? And the answer is whichever one you want to do is fine. One might technically be faster, but if it is, it's like nanoseconds faster. You know, and you would have to be processing millions of comparisons before it would ever make a noticeable difference in your code. Okay, so yeah, so is period bigger than a zero-length string? The answer is yes. Every string that's not a zero-length string is bigger than a zero-length string. All right, so if there's anything in there, this will evaluate to true. The difference between until and while is simple. Until, you're gonna execute as long as the expression is false. While, you're gonna execute as long as the expression is true. It's just a difference between true and false. The truth is, if I was writing the language, I would not have made a different keyword for that, because you could just use not. You could wrap not around it with exactly the same thing. But they wrote the language that way, so there it is. So that should do the same thing. I'll run it again, but this time I'll break into it because I don't want to wait it to go down to 3,000, whatever. F5 should run. And because I have the do events in there, I'll hit the stop button and it will respect that. It'll stop. Without the do events, it would just keep going. Okay, so pretty good. I've gotten now the ability to right. So what would I do? I'm going to uncomment. I'm not going to do this because it would take a long time to pull the data in. But if I wanted to make this now actually import page after page after page of the data, what do I change? I'm going to change this, but what do I put here? Yeah, this expression here that's printing out the sequence of the counties. So now, I still have it commented, but if I had it uncommented when it ran, the first time it would pass in the 1,000, then 1,001, 1,003, 1,005. It just would go one after another. Because it takes several seconds to get this, you know, I'm not going to run it. We have one sheet of data which will let us kind of build the code out. Okay, how are we doing? So far, so good? There's another way out of this. Oh, one question often comes up is, could you put, and remember, we can put the exit condition at the top, or we can put it at the bottom. I think we mentioned the difference. Anybody remember the difference between putting it at the top or the bottom? There's only one difference. What's the difference? That's right. If it's at the bottom, the code inside the loop is guaranteed to run once. But that's the only difference. Okay, I'm going to put it back at the top. So, but then the question is, could I have two conditions? Could I say at the top, get out this way, at the bottom, get out some other way? And the answer is no. I have to pick a single exit condition to put at the top or the bottom. But that condition can be complex. So I could come up here and say, do while this is true. You know what? I work with until so much more. I like until better. I'll move back to until. Do until this equals a zero-length string. It's the same as is empty. Or r is greater than 5. So now the whole condition, as soon as this whole condition evaluates to true, it's going to let me out of the loop. So which of these two conditions is going to happen first? Yeah, r greater than 5. It's going to go like, you know, after 5 times, it's going to do that. So I'll run that. 1, 2, 3, 4. Oh, only 4, because we didn't start at 1. And so you can make that as complex as you want. Realize that that one of the main places that errors get into code, like you have problems in your code, is in complex conditions. The interpreter deals with complex conditions no problem. The human interpreter doesn't do so well with them. So just anytime you say, I'm going to have a couple of ors and an and in here, you're going to do two things. Number one, you're either going to say, I'm going to figure out a different way to do this, or number two, I'm going to be very, very careful with this and make sure I understand exactly what's happening, because that's where errors happen. Complex conditions is one of the main places that errors happen in code. Okay. there is another way out. So you can get out right here. Exit do. If I say exit do, it just drops me, it just say we're done with this loop. Get me out of here. You almost never just put exit do by itself unless you're debugging. You just say, as soon as this goes through once, I want to stop. So you might have some condition. If R is greater than 5, then exit do. And now I'll take this condition off of here because now I've got it down here as well. So you can check for as many different conditions as you want, but you have to do them inside the loop. You only get one that's built into the structure of the loop. But you have as many if statements built into it as you want that will check to see if it should exit. But that should run exactly the same. Questions? Technically, there's one more way out of a loop. It's evil. It involves an evil, wicked statement called go to. And I am not going to teach you that way. Because as soon as I teach you that way, you'll get ideas about how else you might want to use go to. And after you've learned some good habits, I might trust you with such a wicked thing. So there's yet one more way out of this. And someday you might think, I really got to get out of this. Where go to becomes handy is if you have a loop inside of a loop inside of a loop, and you get to a condition you say, I want out of all of these loops at once, go to will do it. And it's the best way to get out of all of them. But that's like the only valid use for that statement. Otherwise, it can just let you branch to a different part of your code, and it makes the code really hard to follow. Okay, so go to is out there, don't use it. All right. So now you're all like, ooh, let me read go to. Sounds great. All right, anything else on the do loop? I think that does the whole do loop. All right, so let's go ahead and extend this example. And what I'd like to do, I'm going to leave this line blocked out. So we're going to have it get the page, and then we'll pull the data off that page. But as we're developing our code, we're not going to have it actually getting the page. The page is there for us to work on. We'll just work on the one page that's there. Was everyone successfully able to actually import that page? Is there anyone who didn't import the page? Okay, so we all have a sheet called sheet 1 that has data on it. Right, so I'm just going to assume that this data is for Alabama because it's going to be the data that's for all of these. And what I would like to do is I would like to put some information right out here. What should we put in there? Let's go ahead and put in, see, what of this information might be most interesting? So we have this date range. You know what? Rather than having the code do the date range for today, I'm just going to copy and transpose this date range, this year range. All right, let's do one more. Let's do it with a loop. So make a separate sub procedure to introduce the for loop, and then we'll integrate a more meaningful example of it. So sub make header. Okay, so here's what I want to do. I want to iterate across this, and I want to take January 2008, and I want to put it right here in D1. And then February 2008, I want to put here. I'm going to be building a table. So I want to put those. I was just going to copy and paste it, but it's not in the same cell. So we'll just use it as an example. So step 1 is going to be to make a loop that goes across that whole thing. Now, this is probably best wired for a do loop. But I'm going to introduce you to the next kind of loop, which is the for loop. Hello, silent phone. So here's the syntax for the for loop. Starts with the keyword for, ends with the keyword next. we've got a little more work to do here on the for. So this idea of saying I've got a loop that I want to run a specified number of times. I know how many times I want the loop to run, and I want a variable to count across a range in so doing is such a common experience in programming that we've got a loop that's just wired for it. We could build this up just with logic of the do loop. We can do exactly the same thing, but the for loop is wired for it. Makes the code a little bit more clean. We're going to need to have a control variable. I'll just go ahead and declare the variable, I'll call it R up here as well. Ooh, is that going to be a problem? I've got two variables named R. Because they're in different sub-procedures, not a problem at all. So now I'll say for R equals, and let's just go and look and see the range that I really want. The first one is in row 20. The last one is in row, let's do 157. I don't really want to deal with the projected numbers. So 20 to 157. So for R equals 20 to 157. So what this is going to do, this is going to say, all right, we're starting this loop. Let me print off, we'll just print off R. And I'll run this with F8 so I can step into it. It says, great, we're now going to give R a value of 20, and now it should print 20. We hit the next, and next increments R. R is now 21. And it prints 21, 22. It's just going to print all of those all the way out. F5 will finish it off. And so I don't have any statement that says R equals R plus 1. Why not? Because next does that. When it gets to that next line, it does that. What if I only wanted January numbers? Let's go ahead and print off what we're interested in here. So that's on sheet 1. Sheet 1 dot cells, row number R, column number. See, we're just going after the header here. The January is in column B. So I can either put a 2 here, or incidentally cells allows me to put a letter as a string for the second argument. So I'm going to print R and comma. Then I'm going to print the value in column B, and then I'll put the value in column A. So this will say February 2008, or January 2008, the first time it goes through here. So F8 with my active cell inside the procedure I want to run. So January 2008, what's it going to print second? What's the next one? February 2008, March, April, and so forth. Well, what if I only wanted to see, what if I wanted January 2008, and the next one I wanted January 2009, January 2010? Someone said it, like they've been reading the book or something. Say it louder. Yeah, step. So it turns out, right here is an optional syntax. If I say step 1, stop my code and start it again. F8. The step tells it how much to count by each time. How much to add, when I get to next, how much do I add onto the control variable? This variable right here is called the control variable. It's the variable that controls the loop. So instead of adding 1, I could add 12. I think that would do it. So now I'll run this with F8. And so it does number 20, and then it skips to 32, 44, 56, 68, 70. It's just going by every 12. It's adding 12 instead of adding 1. That's pretty great. Questions? Okay, now in addition to printing this, what I would like to do is I would like to actually put those headers onto my counties sheet beginning in column 4. So I want to put January 2008 right there. So let me just make another variable for this. dim c as an integer. I think we're only allowed to have 15,000 columns, 16,000 columns. So integer will work fine for that. Then I'm going to print it, and then I'm going to say C equals 4. And then counties, or county, dot cells, row number 1, column number C, dot value equals these two. But I can't put with a comma. The comma only works, this comma only works for debug.print. I can't say put 2 values in there. I've got to first make those into a single value. So I will do that by concatenating ampersand, quote, space, quote, ampersand. Make sure I have spaces around the ampersand, because it turns out in VBA, actually, ampersand is a valid character for a variable. Don't ever do it, but you could put an ampersand in your variable. So you have to have spaces around the ampersand so that the interpreter knows, oh, that's not part of the variable. That's actually a separate thing. Okay, and now I just need to increment C. So C equals C plus 1. So now this should put right across there the January 2008, 2009, and so forth. I kind of like that. It uses our little step here in a nice way. I'll run that, and hopefully we've got the headers plugged in there. Oh, wow, it actually read them as a date. That's okay with me. Okay, how are we feeling about the for loop? What if you came to some condition and you thought, oh, I got to get out of this for loop before I'm done? You would say exit. Yeah, down here, you got to have a do loop that said exit do. You want to exit the for loop, you can say exit for. And that just said, I'm done with this loop. I know I was supposed to go for another 12 iterations, but now I'm done, and I'm getting it. Here's one little quirk about the for loop. Let me go ahead and you run this again so I get a clean run of the data. Oops, wrong one. You run this so I have a clean run. Okay, so 152 is the last one that it does. And after the loop, debug.print R. So after this runs, I just want to see what R is. What is the last value of R in the loop? 152. You might think that that should still be the value of R when it's done. But it's not. It's 164. The reason the loop executes is because R went out of bounds. The boundary here is 157. And so when it prints, when R is 152, it prints with 152. That's great. It gets here to next. What does next do? Next adds 12 onto it, makes it 164. It then checks to the top here and it goes, oh, I'm out of bounds. What if it was exactly 157? If it just printed 157 here, or when it was exactly 157, when we added onto it and made it 157, would it actually run with 157? Yes, because 157 is in bounds. This is the highest legal value. 157 is good. 158 or higher lets me out. So I'm not sure that's important. That's kind of a quirk. It will actually take R out of the boundary that you have. You can exit for, that's the for loop. Questions? Yes?
So why did my code put only one date?
Okay, so if your code only put it in D1, you're probably missing this line right here. Because each time you're printing it into C, and you need to make sure that you're incrementing C each time inside the loop. Was that it? Other questions? Oh, by the way, we have a TA here in class, Matthew James or James Matthew. Matthew James. Joanne comes sometimes. Matthew comes sometimes. If you're like stuck and you're thinking, I'm too shy to really ask the professor to stop and help me figure this out, you just raise your hand. I'll call on you and say, oh, I just needed a TA. And that will be Matthew's cue to go over and take a look at what you're doing. You don't feel like you're slowing the class down, which is okay anyway. Okay. So here's the next step, what I want to do. What I would like to do, so we've run this once and that puts the headers in, that's fine. But now I would like to come here to my get data and I would like to write before I increment R, I would like to say, hey, we just got the data. I want to go ahead and bring that data in. I want to bring in, what should we bring in? Let's do the unemployment rate. That'll be comparable across counties. So I want to bring in the unemployment rate for January 2008 and then for January 2009 and actually bring those numbers so that I put a 3 right there, and then whatever the number is for 9 and so forth. Run those numbers right along. So, but just by a show of hands and give me a score on 0 to 5, if I said go ahead and add a loop in there that would do that, that would just put the numbers across, scale of 0 to 5, how many are saying I'm comfortable with that? 5 being, I could do that. I know I could do that. You know, some of you saying, I'm seeing some 2s, some 4s, some 5s, 3s. All right, what we're going to do for the next 5 minutes is get started with that. 3.5 stars. They're not stars, they're fingers, but. So you know, we're doing something really similar right here. So look to that as your example. And go ahead and try to put a loop in here that will pull that data and actually run the numbers right into row 2 of that sheet. And so we'll take 5 minutes. And if you have a question, raise your hand. Matthew will be there, and I'll be around to help as well. Okay, so the whole purpose of having you work through that is to start off to say, all right, to have some little experience, did I even go down the right road, and was my thinking right? But now let's go ahead and work through that idea together. So because it is so similar to this loop up here, I'm just going to copy all of this right in. The debug.print R at the end I don't really care about, but I've got a couple of variables here that I'm declaring to make this loop work. I'm going to copy this. I'm going to paste it in this block that I've kind of opened up inside my do loop. And I'm also going to tab everything in. So you can, if you highlight a whole block and hit tab, it'll push it in. But I definitely, now that this loop is getting kind of tall, starting off with do, ending with loop, I want to see everything between the do and the loop tabbed in so I can see that structure. Now these dims, I really don't want these in here. Typically, because VBA declares all the variables you're using before your code starts running, I like to declare all of my variables up at the top. You can declare them later on, but I like to just put them all right up here. That's when it happens anyway. Now, do you see a problem? I got 2 R's, that's a problem. So I'm going to name one of these row. So R in this is going to mean for me the row that I'm using to go down county by county by county. Row, variable row, is going to use to keep track of the row that I'm reading the data off of the one data sheet. So now down in here, everywhere I had R, I'm going to change that to row. So for row equals this. And I may even just do this mindlessly without even thinking this is something that's going to have to stay around or not. I'm just going to go find all those R's and change them to row. All I've done is rename a variable. I haven't changed the logic at all. Now this R equals R plus 1 is outside of my loop. I'm going to leave that the way it is. Okay. So now I'm doing a debug.print a row, and I'm doing that same row, column B. I don't care about column B anymore. Which column do I care about? We're at column F, and it's on the sheet called sheet 1. So I'm going to debug.print. Oh, yeah, so sheet 1 is, that's right, that's already sheet 1. So I'm going to do F, and the truth is, I only need one of these, so I don't even need the second half of this. I'm going to comment out this next line because this is the line that actually is writing the data in. And I would like to see this happen in the debug window, the immediate window, before I try to actually write out to my worksheet. So I'm going to comment that out, but the rest of this looks pretty good. I'll clear out my immediate window. And I'm going to run through this with F8. I've got my first county there. And now I should be printing that 3. Yes, I'm on row 20, and I pulled in the 3. That looks good. What's my next number that I'm expecting to get? January, my next January 2009, which is 2.8. So I'll keep stepping through, and if my code is good, then I'm getting the 2.8. I must have clicked up there, which is what brought that up on the same line. Row 32, 2.8. Yeah, okay, so that's pretty good. So now I'm feeling pretty comfortable with that expression. So now I'm ready to put that into my county sheet. Now, here, I don't want to just go to row number 1. That's my header. Which row do I want to put this to? Yeah, whatever row I pulled the FIPS number from. And I've already got a variable holding that, that's R. And then the column, it's going to be the same columns. And so maybe I'll just delete the rest of this and bring in the value that I was printing. Then I'll stop this and I'll start again with F8. We can see it printing in there. Let's take a look at how it's doing here. Get my counties sheet showing and continue to step through with F8. Looks pretty good, like it's doing just what I want it to do. I don't know how many years there are. I guess there's that many. So it looks like I got that data and brought it in. It's delightful. So we really didn't have to change that much. But this is a kind of a big normal process in programming and say, all right, I got something that's really close to what I'm after. Let me just kind of start with that and then think about what I have to do to change. Okay, now that we went through that whole example, you started this on your own. How many of you think you could have done that? You could have worked, given some time, more time than the 5 minutes that we took. But how many of you are saying, I totally could have got there. It might have taken me an hour or more, but I think I would have got there. 5, that's a 5. You know, if you're thinking, I'm not sure an hour was enough, well, actually, hold up the number of hours. If it's less than an hour, hold up 0, up to 5 hours. If it took longer than 5 hours, you'd probably call somebody, you know, maybe email me. So there's a few of you who are saying, I'm not sure I would have got there. That's okay. That's a fine place to be at this point in the course. Is my voice amplified? It means even though I started recording again, I didn't turn on the audio. Amplified before. Excellent. Whew. Makes me wonder if it was on to beginning with. I remembered though. Okay. Okay, so that's the for loop. Yeah, question. Okay, so if you have an error that says sub not defined, that error means the TA is on his way to come take a look at where it's happening. So it probably means you tried to call something that's not defined, but the fact that it said sub is kind of interesting. So Matthew, if you could go kind of take a look and see what line that is, that'd be great. Question here.
So I hit F5 and it like kept running, so it was like go down row.
Oh, it keeps going out. So where are you setting the for, setting the initial value for the column? That needs to be inside the loop so that it runs with the loop. All right, I am going to run this one more time, but I am going to actually bring in another sheet. No, I'm not. I'm going to pretend that we have multiple sheets that we've created by just adding a few more sheets. So here I've got now 3 sheets in addition to my counties sheet. So go ahead and just do that. Just go insert some more sheets. And I want to introduce, in the 5 minutes we have left, the one other kind of loop that there is. So from time to time, and we would have to make our code a little more sophisticated because we are always looking at sheet number 1 here. So we would have to do something to make sure we're looking at the right sheet. But we're going to set that issue aside for now. We can say, listen, I got to run this new data. I want to delete every sheet except for the one named counties. And it turns out the next kind of loop is not so good for deleting things. So delete's probably not the best example for this. Let's just write a loop that lists what those are. And that'll be a good use for it. So sub list sheet names. Okay, the next kind of loop is called the for each loop. And it's kind of like a specialized for loop. The for loop takes an integer variable and moves it across a range. The for each loop iterates across objects in a collection of objects. So I'm going to declare a control variable. I'm going to call this one S as a worksheet. So it has to be some kind of object variable. It could be variant as well. It has to be some kind of object variable. Now we will say for each S in this workbook dot worksheets. Somebody tell me what this workbook dot worksheets is. It's the collection of all the worksheets in this workbook. Now, what this loop does is it says, listen, I've got a worksheet object, right? And we did something like this before. Set S equal to this workbook dot worksheets sheet number 1. Right? Last time we were together, we wrote code like this. Somebody tell me what that does. Go ahead. Yeah, it's going to bind my variable onto, my object variable onto one of the elements in this sheet, in this collection. And it happens in this case, it will be counties. Worksheets is the order they are in the collection is the order in which they show down here. Well, this little line happens automatically as we run through the loop. So the first time through the loop, S is going to refer to counties. Then it will refer to sheet 2, sheet 3, and then sheet 1. So if I say debug dot print S dot name, it should print those names off. In the same way that somebody said, you know what, it is such a common thing for us to want to take a variable expression, a number, and iterate a loop while that number moves across a range. They built a loop for it. It's so common. Same thing here. We want to treat all the objects in the collection in the same way. So we've got this syntax. The only part that's weird about this is that I can refer to S here, and it actually refers to a different object each time through the loop. But that's what it does. It says I've got a variable called S, connected onto the first object, run the code. Connected onto the second object, run the code. Connected onto the third object, run the code. Connected onto the fourth object, and run the code. If you're looking at this thinking, whoa, that's mystical, that's probably an okay place to be. This is the hardest of the 3 loops. It's the most abstract. So, and we'll do several examples as we move through class doing it. But questions on the for each loop? Can you nest one of these loops inside another loop? Yeah, that's what we did here. We've got a do loop, and we've got a for loop happening inside that. Could you nest even deeper and deeper and deeper? Yeah. Yeah, so you can nest to your heart's content. There may be some real limit, but it's pretty high. Question in the back?
Yeah, could that property, like, for in this example, for each essence workbook worksheet, or like the first cell is blank, delete.
So, one more time. You wanted,
If you wanted to, using your delete, say we wanted to delete all the blank space. And the way we knew it was blank is if cell A1 was empty. If you assign S to only the,
oh, just to delete the empty ones.
yeah.
So the question is, you know, could we like look into that? Could we say, if, I'm going to take away delete, because as soon as you have a collection, you start deleting things out of a collection, the for each loop's not a good choice. The for loop would be better for that. But let's say we wanted to only print the name if it was blank. We want to print off the blank names. So yeah, I could do this. I would say, if s dot cells, in fact, we could do it this way, range A1, we'll just do is empty. Is empty. Then debug.print. So now it shouldn't print this one. I don't know about sheet one. Is sheet one? Yeah, sheet one has something in A1. So that should only print sheets 2 and 3 when I run it. So yeah, once I've got that sheet bound onto that control variable, I can do whatever I can normally do with a worksheet. So it's ready to go. Okay, folks, if this last loop is leaving you feeling a little queasy, that's okay. It's the most complex one. We'll do several examples throughout the semester. You'll feel good with it. Thanks for coming. Class dismissed.